Today we're going to learn about atomic models. Introduction. As scientists acquire new experimental results or new experimental data, old scientific models or atomic models must be revised in order to explain the new data. So in the past, scientists have often come up with claims or theories which have been proven wrong by scientists who come after them. So today we're going to talk about John Dalton and his 4 postulates and how most of them are proven to be incorrect. So his first postulate states that elements are composed of atoms and that these atoms are indivisible and indestructible. This has been proven wrong because we now know about the existence of protons, electrons, and neutrons that make up the atom. His second postulate states that atoms of one element are identical but different from the atoms of all other elements. And this has also been disproven because mass spectrometry has taught us that isotopes exist, as do ions. His third postulate states that atoms cannot be changed into other atoms and that these atoms are neither created nor destroyed. And this is how he came up with the law of conservation of mass. This has also been proven wrong because of nuclear fission and fusion. His fourth postulate states that compounds form when atoms of more than one element combine in simple whole ratios, and this is still relevant today, and we still use this, and we now know it as the law of definite proportions. Dalton's model of the atom is called the billiard model.
Here we have J.J. Thomson and his cathode ray experiment. From the picture on the right, we can see that the stream of particles from the cathode is bent towards the positively charged plate. As a result, Thomson was able to conclude that these tiny particles were negatively charged. He then used the results from this experiment to develop a model in which a positively charged atom was interspersed with the negative particles, electrons, from the cathode ray. Next, we have Ernest Rutherford and his gold foil experiment. In this experiment, Rutherford noticed that the alpha particles shot through the gold foil were mostly undeflected. However, there were still some that were significantly deflected. As a result, Rutherford was able to conclude about the atom that there is a positive charge concentrated in the center of the atom, or the nucleus. He was also able to conclude that the atom is mostly empty space, as well as that tiny negatively charged particles travel around the nucleus. In this experiment, we are able to see how Rutherford used his newly found experimental results to change the previous plum pudding model into the one depicted below, in which the positive charge is concentrated in the center of the atom rather than interspersed.
Okay, so now on to the Bohr model. So the Bohr model, developed by Niels Bohr, he postulated it by starting by running through electricity through gaseous elements such as hydrogen, neon, and chlorine. And so he would run electricity through them and give the electrons a higher energy. And that would push them up to higher energy levels. And then after a few moments, they would fall back down to lower energy levels. And they would release that previously absorbed energy in the form of light. And for every element, it would be different. And so from that, he was able to conclude the following, which were that electrons are only found in specific circular paths called orbits, and that they can only move from one orbit to another, and they can't move like in the middle of an orbit, that they have to move from orbit number 1, say, to orbit number 3, and then back down to orbit number 2. They can't move from orbit number 1 and then go only up to like halfway in between orbits 1 and 2. And so from that, he created a model of the atom, which, like previous models, there was in the center the protons and neutrons, and then around in little circles those were the orbits, and then there would be electrons spread out in those orbits. And we now know that that's incorrect. And modern model of the atom, we base it off of many different things, one of which is the Heisenberg uncertainty principle, and that states that it is impossible to determine simultaneously both the position and momentum of an electron or any other particle with a great degree of certainty. Like, if you have an electron, you can't determine both where it is and what way it's moving.